Hey, Christian. How are you? Hey, Garrett. How are you?
Give us Sparks.
Y'all having a good day?
Yeah, actually I am.
Oh, good. I love to hear that. I'm glad that a late math lab worked out because my niece has been in the hospital for a couple days. I say niece, a lot of people, that makes people think of a young person, but she's actually only 2 years younger than me. But she had a weird bleeding on the brain, but she's doing great, and they released her. So, so this kind of worked out. So I appreciate you all being so patient and cooperative with me with my wonky schedule sometimes.
Mm-hmm.
But let's do this. All right.
Completely, I don't really understand this at all. I haven't watched
Okay.
the videos. I've been working on other stuff, but I just don't. Also, my calculator died. But I haven't had a chance.
Oh my gosh, that's terrible, Garrett. You cannot do these without a calculator.
I have one on my computer, but it's just a little slower.
Oh, okay, baby. I was like, oh, you need to use your phone, or you need to get your, like, just even, in all honesty, a calculator, like a checkbook calculator, like anything. It doesn't really have to be too of a complicated. Like, I can turn my phone. Actually, most things I can do on most things I can do on my phone. But anyway, one other thing I kind of want to check. Okay, hang on. Sorry about that. The first thing that you really kind of want to reference with regard to these is to make sure you have your formula, because that's on the geometric. That's pretty crucial. Actually, on all of these, for the most part, it's pretty crucial. So I'm just going to write that up in the right-hand corner, or at least I'm going to attempt to write it on the right-hand corner. The goal is to A sub n equals, and then the value of your first term, that's what that A sub 1 means, times, and then that common ratio, and then that will be raised to the n minus 1, which basically is like if you're being asked, if the n down here, let's say that you're being asked about the 8th term, then this n minus 1 over here would be 8 minus 1. And the reason for that being is you're already incorporating the value of that first term by saying A sub 1. But let's take a look at that. Take a look at a couple of them and walk through that and see what that looks like. Okay, so what I do to find the common ratio for me is I take the second term and divide it by the first. And to confirm, when it says determine whether the sequence is geometric, you then again want to do it for the third term.
Can I do a subtraction with the other one?
Yes, yes, very good. Awesome. That's it. Perfectly. So you would divide 128 divided by 16, and you would get 8. So it is a geometric sequence, and the common ratio is 8. And then what you're going to do from there, once you have that common ratio, it says you're supposed to identify the common ratio and then give the next 3 terms. So at this point, what we're seeing is all we have to do really to do this. We don't have to use the, because we're not looking for a specific term. We can basically just take the next and just keep multiplying that by 8. Does that make sense?
Mm-hmm.
Okay, good. So now the next step for me would be to take 128, multiply that by 8, and I'm going to get 1,024. And then I'm going to take 1,024, multiply that by 8, and I'm going to get 8,192. Then I'm going to take that term and I'm going to multiply that by 8, and I'm going to get 65,536. So that's what you're doing there. Now on number 2, it's like, oh, wow, it's going down. So if I take a negative 900 and I divided it by 2,700, what I'm going to do in this scenario is you need to be, this is where your brain needs to start looking for patterns. And I'm going to see that 900 goes into 2,700, that's really going to reduce more like a fraction. And I'm going to see negative 1/3. And I get the negative from the fact that this is positive, this is negative. And now this is positive again. So I realize that, I'm probably going to have some sort of ratio here. Once again, what I'm going to do is take that 300, confirm that it is a common ratio. And in fact, it works again, 1/3. So it is a geometric. The answer is yes. And the common ratio is negative 1/3. So now when I take 300 and I'm going to be multiplying that by a negative 1/3, then I'm going to get negative 100. And then when I take 100, negative 100, and I multiply it by a negative 1/3, that gives me a positive 100 over 3, which 3 into 100 is 33.3, repeating, because if you take the negative 100 and plug that in, and now I'm going to take a positive 33.3 and divide it by a negative 3, because technically if I was multiplying this by 1/3, I would end up with 33.3 over 3. Does that make sense to you? Really, multiplying by a negative 1/3 is the same as dividing by a negative 3. Does that make sense?
Mm-hmm.
Okay. So then I would have a negative 11.1 repeating. All right, now here I've got 10 divided by 5, which gives me 2, and then 30 divided by 10, which gives me 3. So that is not a common ratio. So it is not a geometric sequence. And number 4, I've got 12 over negative 3, which would give me a negative 4.
It's negative 4 is the constant.
Yes. And I just always kind of like to kind of confirm it, So, yes. Is that making more sense?
Yeah.
Okay, good. So then I take that negative 48, multiply it by a negative 4, and I get 192. And then I take 192, multiply it by a negative 4, and I get negative 768. And then I take negative 768, multiply it by a negative 4, and I get a 3,072. All right, and then on this one, basically what I can kind of see going on here is that everything's being multiplied by 1/2 or divided by 2. You could look at it that way as well. But I can see if I have a negative 1 and I go to a negative 1/2, and I go from negative 1/2 to negative 1/4. I mean, this is how you would do that, which then looks like this. Like if you took keep. And then if you took 1/4 and divided it by 1/2, you're going to see that your common ratio is negative 1/2. And I'm figuring I'm going to need all this to write. So negative 1/4 times 1/2 is a negative 1/8. Negative 1/8 times 1/2 is negative 1/16. So you can kind of see that you're continuing to go into the hole here. So you're basically doubling the denominator at that point. Nine over 8 doesn't really reduce. 10 over 9. And that is not a common ratio because you're just basically subtracting 1. So the answer is no.
I understand those problems.
Arithmetic, yes. Geometric on that one, no. Okay. So now to write a rule. So what do you think is going on here on number 7? What do you see going on?
Doubling.
Yeah, good job. So your common ratio is 2 because when you double something, so now what we want to do is take our formula that we wrote down up here.
Is it -2?
Yes, good job. Good job. So we're going to take our formula there, and then that A1, that first part right here, that's A1. So the value of A1 times, and then you're going to take what the common ratio is, which you told me is a -2, and you were spot on. Okay, so you're going to put that in because that's what the R is. So the A1 is the value of the first term. The R is the ratio, the common ratio, which you told me was -2. And then that's going to be raised to n-1. And remember with the arithmetic, how you had to distribute that, n-1 and get it kind of combined in to the rule. Here, you just leave, you're done. Once you plug in stuff, you're done. So that's kind of the cool part about that. Other than now what it's asking us to do is to find that 8th term. Didn't mean to color right over that. Find the 8th term. So you'll plug in 9, for the value of the first term. And then -2 raised to the 7th power. And so, a couple things I know going from there.
So you just throw in whatever one you're looking for, like one less?
Yes, sir. That's it. Exactly. No more complicated than that.
That's actually pretty easy.
Oh, I think geometric are so much easier, in my opinion, than arithmetic. Just because
they're both easy, but this one's easier.
Yeah. And it was weird. It's weird because I feel like a lot of times when you're writing the rule for an arithmetic, one of the most common mistakes is to not distribute that, the common difference through that n-1 parentheses, because it kind of gets melded into the equation. You know what I'm saying?
Mm-hmm.
And so that makes it difficult. This just is very straightforward in the fact that you're just essentially once you find that common ratio, you're just plugging in values to me. So like number 8, it looks like if I took 15 divided by 3, that's 5. If I took 75 divided by 15, it's 5. So my common ratio is 5. I didn't write the common ratio over here, but I wrote it in. So now what I'm going to do is just take my formula and start plugging in the things I know. I know the first term is 3. I know the common ratio is 5. And then it's n-1. So if they're asking me to find the 8th term, then I've got 3 times, and then 5 raised to the 7th power. And 5 raised to the 7th power is 78,125. And so then my final answer is 234,375. All right, for number 9, if I take 1,600 and divide it by 6,400, I can see that I'm going down by 1/4 or dividing by 4 each step of the way. So got a to the n. And then I'm going to plug in the value of my first term, which is 6,400, times 1/4, because that's my common ratio, and then n minus 1. And then once again, what we're going to do is find the 8th term, 6,400. And then we've got 1/4 raised to the 7th. Oh, this is fun. 6,400, and I'm just going to do 4 raised to the 7th power. 16,384. So that's basically 6,400 divided by 16,384. That's fun on the calculator.
The phone calculators are annoying because they don't show you everything at once. They every time you hit a key, it just kind of factors in. It doesn't show you what's going on until you've hit equals.
Yeah, I know. And so you're like, ooh, did I really plug in everything right? So 16,384 equals. Did you get this? 0.390625?
I couldn't get it to work because it's hard to get it to work.
Okay, if you turn the iPhone sideways, the calculator's bigger.
Yeah, it still does the same thing though.
Oh. I just did
I'll do it though. I'll give it a shot.
I was going to say just do 64. What I do is try to take it steps at a time. 6,400 and then divide it by 16,384. Let's see what you did.
That worked out very well.
You didn't get 0.390625?
Well, my calculation is probably garbage because it isn't. It's hard to see.
Oh, okay.
I'm gonna give.
Well, I'm hoping that that's right. Let's see. All right, so for number 10, 4.5 divided by 1.5 is 3. And then 13.5 divided by 4.5.
I got the same thing.
Okay, good. Okay, so if both of us got it, we have to be right, right?
We can both be wrong.
I guess that's true. Negative 1.5, we just plugged that in because that's the value of the first term. And then I got the common ratio as -3. -3. And then n minus 1. And then so the 8th term is -1.5 times -3 raised to the 7th power. And so I know I'm going to have a negative answer because that's an odd exponent. So -2187. So it's going to be 3,000. I got a negative number times a negative number, so that's going to give me a positive 3,280.5. The common ratio for number 11 is 7. But just so we can get to some of the rest of them, I'm going to move on to the one that's a little harder. The fraction, I'm figuring you want that one. And what I try to do with fractions, if I can get away from actually, you could obviously do 8 over 27 divided by 16 over 81, which then looks like 8. Keep, flip, and then change. Which is 3/2. And you could do that to 4/9 as well. But the other way, does that make sense?
Yeah.
Okay. All right. And then, so then you would take 4/9. And basically what you're doing, if I take the premise of this, then I would do 27 over 8, which then I would get 3/2 again. So the common ratio is 3/2. So I'm going to erase that. So now we have to find, this will be fun. So now we have to find the 7th term. And this is when it would be nice to have the regular calculator because it would be fun to just take 3/2. Like if your calculator hadn't died and mine hadn't died, we would be able to plug in this straight into the calculator. You know what I mean?
Yeah.
Let me see. Let me see what I can work out. That okay, that's going to be the same as 1.5. So I think I might do it that way. 1.5 raised to the 7th power. Is it very long? Let's see.
Is that 17.0859372?
Yeah. But I'm trying to see if I did it right. 3. Because I'm trying to use the wonky calculator, so
It's 3.375.
yep, I finally got it. We got it at the same time. Bless you. That was killer on the calculator, on an iPhone calculator anyway. Okay. Now, for this one, really, these are really easy when they're geometric because it's asking you to find a to the 7th. And you have the first number, which is 4. You've got the common ratio, which is 6. So then you're just doing 7 minus 1 right here. Does that make sense? I'm just going to plug it in. 7 minus 1, which basically, so a to the 7th, it's always going to be 1 less than the number that you're looking for because you're incorporating it right here. So it's really not that bad. You know what I'm saying?
Yeah.
On number 14, we don't know what a to the first is. So we have to find it. And in order to find that, what you do is solve for it. What we do know is the common ratio and what the 8th term is. So if we figure that out, we can put this in for a to the 8th. We don't know what this is, so we're just going to use it like it's a variable. We're actually solving for that piece of the original equation. And then we're going to plug in that common ratio, and then 1 less than 8 is 7. So now we got 1,024 equals a to the first times, and then negative 2 raised to the 7th power is negative 128. So I'm going to divide both sides by a negative 128. And so it's negative 8 equals a to the first. So now I'll plug in, if I'm looking for a to the 4th, I'm going to plug in that negative 8, which now we know the value of that first term, right?
Mm-hmm. And
then the common ratio raised to 1 less than 4, which is 3. Well, that's just going to be negative 8 times negative 8, because negative 2 raised to the third. Oops. I don't know why I wrote a negative 6 there. Negative 8 and negative 2 raised to the third power is a negative 3. So the 4th term is 64. That makes sense?
Yeah.
Okay.
I kind of want to do the rest of these just to make sure, because I understood the last one's a bit better.
Okay. The number 15 is a little more like 14. Do you want to walk through that together? Is that what you're saying?
I like watching and then trying to figure out how it works.
Okay. Okay. So, once again, we're going to solve for a to the first, and that's what they want to know is a to the first. Thank goodness. It's a one-step process here. So we got negative 27 equals, not a to the first, but a sub 1 times, and then you've got your common ratio, which is where you're plugging in now, and 1 less than that. So it's 2. So negative 27. So that's going to be 1/9. So to divide by 1/9 is the same as multiplying by 9. So I'm going to multiply both sides by 9. So that's going to be negative 243 is the value of a, is the value of the first term, a sub 1. Now on this one's a little stranger. We've got 337.5. So we've got a to the 4th. We've got the value of the first term. We got the value of the fourth term. So let's just plug in everything we know. And we know that we're looking for a sub 2. What we know here is that that's the fourth term, but we don't know the common ratio. So this is going to be times the common ratio. And if we're setting it equal to the a to the fourth one, or a sub 4, or the fourth term, then we know this is going to be raised to the third power, because it's one less than where the term is. But the value of the term is 37.5. So very first thing we want to do is divide both sides by the 2400, because we're trying to isolate that r. And this is already an ugly variable. I hope my calculator does this. Let me see. Clear. 37.5 divided by 2400. Okay. I don't know if I can do a cube root. Let me see if I can. Oh, I can. Good. Thank goodness. If I can't do a cube root on this one, does your computer calculator do that stuff?
I'm using my phone calculator.
Okay. So now I need to take the cubed root of both sides. Let me see if I can do this backwards. Ooh, it worked. What did you get? Just to make sure I say it worked. I got all excited. I'm hoping this worked.
I didn't do it because I don't have the calculator to do it right.
Okay. 0.25 is the common ratio. So now I'm going to plug in what I know. And I know the first term, which is 2400. I know the common ratio, which is 0.25. And I'm going to plug in, and that's actually to the first power because it's one less than the term that you're looking for. So we're looking for 2400 times 0.25, which basically that's a fourth of that. So that's 600. Could you do that all by yourself at this point?
Probably not that one because it was a little weird, but I understand how you did it.
Yeah, it was a little weird, wasn't it? Yeah. All right. Well, number 17 is a little like it in that we're going to plug in what we know. So we know that 75 is the value of the fourth term. We don't know the value of the first term, or we don't know the value of the first term, but we know the value of the second term. We don't know the common ratio. This is the difference between these two. Right here. Because the ratio would be squared. Because here you're taking, instead of taking the fact that here it was 4 minus 1, because you had the first term and the fourth term. Here it's 4 minus 2.
Wait, why did you put a 2 right beside the R if 75 is a 4? Wouldn't it be a 3?
That's what I was explaining. Up here we could use the third term because we had the first term and the fourth term. This time we've got the second term here and the fourth term. So the power is the difference between the two.
Oh, okay.
It worked over here in number 16 because it was the fourth and the first, because we had the first. But when you don't have the first, you have to use the difference between the two that you're using. because the ratio you would just be multiplying each term by that common ratio. So you're just looking for it to be raised to that power of distance. Does that make sense?
Mm-hmm.
Okay. And it's only 2 away. So you want to find that common ratio, it's only 2 away from it. So what we're going to do is divide both sides by 48 first. And we're going to try to reduce that. And really what you want to do, we're going to hope and pray.
I got 1.25 for R, but it's probably wrong.
No, you're right. You're definitely right because you took the square root of each one.
Yeah.
Okay, because I was going to say this. I noticed that 3 goes into both of them. I was going to cheat. I noticed that 3 goes into both of them, and then I could take the square root, and I got 5 over 4. But that's the same as you said. It was 1.25.
Mm-hmm.
That's the same thing. So it's good. And so now we're supposed to find A1. So what I would do is take your value of 48 and divide it by 1.25. Because A1 would equal whatever A2 was divided by the common ratio, because I multiplied A1, right, by the common ratio to get to A2. Does that make sense?
Yeah.
Would you be able to do it on your own, though?
Probably, yeah.
Okay, good. Just it's reasoning that out.
Can I just have just a second, please?
Sure. 48 divided by 1. Just confirming. Yep. $2.50.
Okay, I'm back.
Okay. Basically, I'm kind of setting number 18 up just like I did 17 and 250. So I'm going to divide both sides by 16. And I can reduce it. I can take it 250 and 16 are both divisible by 2, which gives me 125 over 8, which also happen to be perfect cubes. Praise God, because you needed to take the cube root of both sides. So the common ratio is 5/2. And so now what I'm going to do to find, I'm supposed to find what? A sub 8. I think I would actually, to get to 8, I could go from 6. That'd be 250. And I'd be 2 away from 6. So I would just raise that to the second power. I would take the A sub 6 Does that make sense?
Mm-hmm.
And then let's make 250 times 25 over 4. Let me see what I get. And I'm kind of using, I think this is why I like geometric, because to me, it's a little easier to manipulate through some of the higher terms and to manipulate the equation. I don't know why. I'm just more comfortable with it. I always think that they're easier than arithmetic. And whoever would have thought multiplication was going to be easier than adding, right? Jameson opened a new savings account with $1,500. The balance of the account for the first 3 months is given in the table below. Write a rule to represent the balance of her account. The estimate, and then estimate the balance of the account in 2 years. Well, first of all, you need to find out wherever she's banking, because this is an awesome rate. Because if you take 1545 divided by 1500, that's 1.03. That's the common ratio. And then this is actually being compounded monthly. So in 2 years, since it's being compounded monthly, that's going to be 24 months. So we want to find out where she's going to be in 24 months. So we know what she started was 1,500 times, and then the common ratio, or the rate that she's getting, is 1.03, and it's going to be raised to the 23rd because it's one less than what we're looking for.
That makes sense.
This is some weird number like this. And it goes on.
I still haven't figured out how to raise things to powers on my calculator here.
If with the iPhone, if I turn it sideways, that X to the Y. Do you know what I'm talking about?
I see it.
You see it? Okay.
Mm-hmm.
You and I both are struggling with our calculators dying, and they're so expensive.
Well, it didn't like die. It just ran out of battery.
Oh, well, you're so much better off than me. Mine literally died. I'm so sad. Okay, Brady dropped a bouncy ball from a height of 64 feet. After the second bounce, the ball reached a height of 36 feet. Write a rule to represent the height of the ball after each bounce, and then find the height after the fourth bounce. So I'm basically going to be looking for the sequence A to the fourth. And then I've got actually, this says that when you're dropping the ball, because it's dropped, it says it's a second bounce. So somehow I have to account for that. So I'm going to do A sub 0 and then A2 to the 30, and that's going to be the equivalent of 36. So there's a distance because it dropped it. And so it's talking about the second bounce, so coming back. Because it dropped it from here. So that's not included as a bounce. So that's why it starts at a height of 64. So when it came down and bounced, it came back up to a height of 36. So you've got A. So your formula looks more like this. So you're actually going to plug it in. Because there's a distance of 2. So this is a little like some of those where we're actually having to take the square roots. Which then reduces to 3/4. So now we're going to plug in That's interesting. Did that make sense?
Yeah, I did.
Okay. I kind of started quit talking because I was trying to work on my calculator and do that. What were you going to say?
That's all the problems.
Yep. Yeah.
Thank you so much, Ms. Sparks.
Oh, no problem. I mean, did she have you all finish yesterday's? Like, did y'all have to do anything from that worksheet, or did you get through the whole thing?
I think we got through most of it. Actually, no, we finished it.
You finished it in class, the other worksheet?
Yeah, we're good. I got finished everything.
Okay. Hey, Christian, did you have any other questions?
No, I did not. I've just been working through it along with
Okay.
Yeah, looks great.
All right. Well, good. Good. Glad to hear it. Y'all email me if you have any questions. No problem. Y'all have a good night.
You as well.
All right. Bye-bye.
Bye.